At the end of the meeting. At the end of the meeting. And that's the AI. Alright. So, did it start? Yeah. Recording? Your screen. It's recording? Alright.
You guys watching the recording? Is it recording?
Yes, it is recording. Okay. This is good. What's up, guys? Welcome to our first general body meeting of the year and of fall 2022. What's up? And today's meeting is a pretty special meeting. We're going to be collaborating with ACM. So, round of applause for them. Yeah, let's go. So, if you guys were at our first AI meeting, and this is your first introduction to ACM, then they have a great, I'll let him explain it for ACM, but if you're part of ACM and this is your first time at AI Club, welcome. You guys are gonna be learning a lot about artificial intelligence. You guys need no experience in it whatsoever. You guys are gonna have a great time. You guys are gonna be learning a lot of hands-on projects, a lot of hands-on work, a lot less of me talking, a lot more of you guys doing. So if you guys are new, welcome to the club, and we hope to see you guys for future meetings from here on out.
All right, yeah. Hey, everyone. I am Anthony. I am the president of ACM. We are doing as he said, our collaboration meeting with Santa Cruz AI today. Welcome anyone that is in AI Club that is not in ACM. Yeah, pretty much ACM is a very general computer science club for anyone that doesn't know. And we are going to be very focused, much like them, on a lot of hands-on projects over the course of this quarter. And over the course of the next quarter, we're going to be focusing a lot on professional development. So yeah, if you are interested in CS or CS generally, or looking for a career in CS later on in your time here, definitely come by ACM. We're going to be doing a bunch more collaboratory meetings like this with all kinds of other CS clubs across campus, and I hope to see you guys there. Thanks.
All right, hello everyone. We're gonna start the general meeting now. So first off, I'll ask you guys, what do you think artificial intelligence is? So we'll start off by just discussing amongst ourselves, people next to you, small groups, discuss what do you think artificial intelligence is?
Damn, okay. Damn. What is artificial?
Give me a thumbs up when you guys are done discussing. All right, we'll give everyone about 10 more seconds. All right, let's all come back together. All right, so I'd like to hear some of your guys' ideas for what you think artificial intelligence is. So raise your hand if you want to give an example of what you think artificial intelligence is. Oh yeah, I see your head. Yeah, go ahead. Yeah, that is definitely one of the definitions. I'll explain later about what I mean by that. It is a good example of what artificial intelligence can do and what helps make it up. Any other ideas of what people think artificial intelligence is? Yeah. Yeah, learning over time, that is a big key in machine learning, which we will talk about in a bit. And machine learning is a subset of artificial intelligence. So again, good answer. Do we have any other ideas of what people think artificial intelligence is? I heard a lot of discussion, so I know you guys have ideas. All right, we'll move on to what artificial intelligence really is. So really, artificial intelligence is a very vague term. It doesn't have a solid meaning, but the general gist of it is anything that is where a machine has some sort of intelligence. Many people like to call this when a machine thinks like a human. Others say it acts like a human, but there's many definitions for what artificial intelligence is. For this club, we'll just define it as anything that has some form of intelligence. And so this is different than just something with a predetermined response, such as hello world, where it prints out hello world no matter what you do. So we'll go on to the next slide where we'll try to guess whether or not this system is part of artificial intelligence or not. Right here, everyone's seen this before. It's a simple if else statement. We'll do a small poll of whether or not people think this is artificial intelligence. Raise your hand if you think this is artificial intelligence. All right, no one. Who would have guessed? All right, who thinks this is not artificial intelligence? Raise your hand. Yeah, you guys are all correct. Believe it or not, this is not artificial intelligence. This is very basic and is typically not deemed to be intelligent on its own right. We will see some other examples of more complex examples. So here, this is a neural network. We will explain a lot more later on in the year and throughout this meeting about what a neural network is. You'll see this a lot. Raise your hand if you think this is artificial intelligence. All right, I see a lot more hands than the original one. So this one, right now, raise your hand if you think this is not artificial intelligence. All right, so from what I'm seeing, it's most people think that this is artificial intelligence, and that is in fact correct. This is something that is plays a very key role in a lot of different artificial intelligence modules that we'll go into a bit. But essentially, it comes down to having a bunch of different interconnected layers, similar to how neurons in our brains work, which again, we'll get on later. So we'll go into the last examples. So this right here is a decision tree. It looks very similar to an if-else statement where we have whether something is one thing, go down one path. If it's not, then go down the other until we hit a result, typically known as a decision tree classifier, as it often classifies. This is just a very simple example, but in a general sense, raise your hand if we think a decision tree is part of artificial intelligence. Raise your hand. Okay, I got one person. All right, who thinks this is not artificial intelligence? All right, still not too many hands. So it seems like I'm pretty sure everyone is unsure of this one. This one's kind of, well, could be either one, and you'd be correct. Most people do classify decision trees as artificial intelligence. But again, because artificial intelligence is so vague, this doesn't have a guaranteed answer as to whether or not this is part of artificial intelligence or not. But typically when you see more complicated versions of this, it would be deemed as artificial intelligence. Next slide. So there's three main levels of artificial intelligence. In our case, for the sake of the meeting and future AI Club sessions, we'll be mostly going through narrow artificial intelligence and general artificial intelligence. So artificial narrow intelligence is when we have an artificial intelligence module that typically solves one task. So think of a chess robot that does only one thing. All it does is plays chess. It doesn't answer your questions. It just solves chess. Then we have artificial general intelligence. So it's a step above narrow intelligence. It has a little bit more than one functionality. So think Boston Dynamics robot. It can run, it can jump, it can balance a little bit more. It has some vision attached to it. A bit more complex than just a simple chess machine. On the other hand, we will definitely not be discussing this very much, but artificial super intelligence. This is what you see in your sci-fi movies. Think The Matrix or Terminator. These are these over humanly like robots that either are equal in intelligence to humans or even greater than. Again, none of us here are Albert Einstein or anything. Hopefully, maybe there is, but this is far future, and we will not be going too much into depth on how to make one of these. Next slide. So the majority of this meeting is going to be talking about the different subsets of artificial intelligence. Similar to computer science, artificial intelligence has a lot of different parts within it. Like with computer science, there's networking, artificial intelligence, website design. Artificial intelligence is broken up into a lot of different categories. The main one is machine learning. As you saw on the first slide, we are the Artificial Intelligence and Machine Learning Club because those two words do go hand in hand a lot. We'll go into all of these in a bit, but there's also deep learning, which is part of machine learning, natural language processing, expert systems, robotics, machine vision, and speech recognition.
All right, so the first and probably one of the most popular subsets of AI would be machine learning. And as a part of machine learning, we also have deep learning as a subset of that, which uses the concept of a neural network, which we will also be talking about later throughout the year. The main thing with machine learning is that you get data and you want to predict something using that data. Very simple to wrap your head around, which we'll be obviously going over more as we go throughout the year. And applications, literally everything. If you think about it, if you're thinking of anything random right now, you could probably find a way to apply it with machine learning. Anything that you can think about, there's some correlation with machine learning as well, which is what makes it very easy to get into. And this is a field that you want to be in.
We'll see in future slides about the different subsets. There will be a lot of overlap between these different subsets of artificial intelligence. So oftentimes we'll be talking about a subset and it'll also be related to machine learning.
Right. Next is what's called natural language processing, which is more or less getting computers to understand human language. So a really simple example of this, or not even simple, it's super complex, right? Is translating from English into Mandarin, which is possible with people who know both languages, but getting a computer to do that is a lot more complicated because computers don't really have an understanding of how our languages work. So it's a massive, massive task. It is, in my opinion, probably the largest span of artificial intelligence or machine learning, solely because everything that we do deals in some way with text. If you're looking to search something up on Google, you're going to be dealing with some sort of natural language processing. If you're wanting to have an interaction with a chatbot, that's natural language processing. Machine translation, like I already mentioned. If you're doing what this is over here, like analyzing what parts of the sentence are positive or negative, or if it's referring to chat support or whatever, that's part of natural language processing. You can get a computer to understand parts of different sentences. All of that, everything to do with text. If you want to generate an entire story, for example, or summarize an article, everything that you can wrap your head around that has some way to do with text falls into the span of what counts as natural language processing.
Yeah, and so now we're going to get into expert systems. So expert systems are models that are designed to simulate human judgment in a specific field. So if you think about ML, you may usually think of, oh, you're collecting data, you're curating a data set, and then you're using that to predict your outcomes. In this case, your knowledge base in this case is curated by a human expert. This is then given to a knowledge engineer in the diagram. To code an inference engine. So basically your model at that point, and then you have a human interface to interact with this engine so that you can use your data to predict conclusions. And then application. Okay, so what do you guys think are some applications of expert systems? All right, see you in the back. Okay, that's definitely one, and one of our applications. There's a very very well-known expert system called Mycin. Does anybody here, has anyone ever heard of Mycin before? Okay, no, that's great. So Mycin is a expert system that was developed in the early 1970s, used to identify strains of meningitis for which then patients would be prescribed antibiotics. And that was something that was done with expert systems. All right, next we have robotics. Robotics, it's just the designing and manufacturing of automated robots, usually just to simplify things that humans would normally do. So anything automated like factories and stuff like that, you would normally find robotics in. It does build off a lot of computer vision, deep learning, and speech recognition. And some applications of that would include SophiaBot, that was created by Hanson Robotics. And then a very recent example would include Optimus, which was released this weekend by Tesla.
Next subset of artificial intelligence is computer vision, which is pretty much allowing the computer to get a visual input and the computer makes decisions based on that. So what do you guys think are some applications of computer vision? Where do you guys think you've seen it before or know of it before? Yeah, absolutely. Saw your hand go up. Does the same thing? Is that, I'm gonna assume this, yeah, what's up? Yeah, definitely, to see who's coming in and out. Rovers, for sure. Yeah, there are a lot of applications of computer vision. That field is growing a lot day by day, and you see the push in companies, especially in this field. So like Google Translate, you can put your phone up to a sign and you can read it. Like Google Lens, putting it up to an object. What is that object? Who is that person in the security in that security footage? Where is the line drawn? Where can that car change the lane, or where should it stop? All of those are perfectly great examples of computer vision, and that field is only expanding.
Then we also have speech recognition. So speech recognition is just enables a program to interpret spoken word and audio. I'm gonna ask this up front because there's some very big examples. Does anybody know where speech recognition could come in handy? See in the back? Can you give an example, more specific one? Google Assistant. Does anybody have another one? Yes, in the back. Siri, okay. Anybody else? Yes, you right here. Alexa, yeah, perfect. Everything pretty much in your daily home use, you can find speech recognition, and it's very, very common in our daily lives.
So those were all the subsets of artificial intelligence. Well, actually, there are technically more, but those will be the main ones that we'll try to cover throughout the year. So next part is going to be about vocabulary. These are going to be keywords that you'll hear throughout the quarter if you stick with the club, and you'll be important to remember these. It's okay if you forget, don't need to really take notes, because we will again redefine these when the time comes. So first we'll talk about the three main types of learning. We have supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is when we try to learn from data that is labeled. For instance, if we look at the fruit basket in the bottom corner, we can label each of those fruits. For example, the red one is going to be labeled as an apple, the yellow is the banana, and so forth. Then when we go to train that model, it knows what each of those items are. So when we go give it, for example, a red circle, it will classify that as a red apple. However, unlike supervised learning, unsupervised learning is more for pattern identification rather than classification. So in this case, there is no labeling of these data sets. So if we use the same example, instead we would give the model the exact same picture, but we don't tell it what everything is. So all it sees is a red circle, an orange circle, a yellow blob, and another purple circle. And so we train a model off of that. And then when we give it, for instance, a red circle, it doesn't know that that's an apple. Rather, it knows by association that it is related in some way to the red circle in the training model. And so this is good for clustering and pattern identification through association. The last one is reinforcement learning. Reinforcement learning is unlike both supervised and unsupervised learning, where there is no base learning data set. Rather, it learns on the fly. So if anyone's ever seen a Code Bullet YouTube video, that is a perfect example of what reinforcement learning. So essentially, it's just trial and error. So you start off with nothing. And so if you're trying to get a robot to walk or trying to teach a robot to walk, you can set a reward to see whichever one gets the farthest. And so you optimize to see however you can get as far as possible. And so as you go throughout the process, you learn and you take whatever has the highest reward or also the least penalty, and you use that and you keep learning off of that to get the best model. So this will be often seen in self-driving cars. Thankfully, they don't just throw a self-driving car with nothing in it, so it doesn't just randomly run into things. They are pre-trained a little bit, but for the most part, they are learning as they are driving.
All right, some other vocabulary that you're going to see. Hyperparameter. A hyperparameter is something that you set before you train the model. So for example, how often you want the model to run. So given an example of a linear regression model or something similar, the goal of that is to optimize a line of best fit just based on a whole bunch of points. And you want it to get really close based on unlabeled data, more or less. So that needs to run a few hundred, a few thousand times if it's a lot of data. So a hyperparameter allows you to set a hard cap. And the hyperparameter in that sense is the amount of times that you could run at most or before it reaches that point. Classification, more or less just, is this 1 or 2? It's that top image over there. And then regression, like I mentioned, is where you might use the hyperparameter. It's just fitting a model to a set of data. It's generally speaking, you're going to see a lot of classification if your data is labeled, and you're going to see regression if your data is unlabeled. At least in some form, and that is a bit of an oversimplification. But More or less, you'll also see this generally for classification if you're looking at, say, an object classifier, to put it literally. So if you're pointing a camera at something like you would with Google Lens, it's going to tell you with some amount of certainty what type of leaf from the plant that is, or if that's a cat or a dog. And then for regression, God, I don't know. Linear regression is a pretty good example. I'm not going to try and think of something off the fly here, but more or less, these are the classification and regression are main types of how models work, and hyperparameters are just how you tune that ahead of time.
It's okay if you don't memorize all those again. We will be going over those later when we do apply them in later lessons. So a big example of artificial intelligence that people probably have seen in social media or in the news is DALL-E. DALL-E is actually a generative adversarial model, also known as a GAN. So we'll just give a quick overview as to how it works and what it does. So a generative adversarial network essentially works with having a discriminator and a generator. So a generator attempts to generate images. It does that based off of a set of training data. So if you give it a bunch of images of stop signs, it will try to generate a bunch of images of stop signs. And the main part with DALL-E or GAN's work is that they have something called a discriminator. A discriminator's job is to identify whether or not an image is made by the generator or was one of those input images. And so those two will go, quote unquote, fight each other to both improve together at the same time. So while the generator is slowly getting better, the discriminator is also getting better. So these two will keep fighting each other until eventually we say, okay, we're done, and we just take the generator's information. So then we get a bunch of information or a bunch of images that we can generate on the fly based on those trained images. And so DALL-E takes this a step further and makes it so that you can give it any text. So that could be literally anything, doesn't even have to exist in real life, and will attempt to generate images based off of that. So this image right here, it shows a realistic graffitied stop sign in a busy street at dusk. Very complicated. So not only does it have to read it through natural language processing, but it has to generate an image that specifically follows those requests. So it's not just finding an image on the internet, it's actually making it on its own. And as we can see, those are some pretty nice photos. They might not be perfect, but those are really nice, and they're at dusk. They're a picture of a nice stop sign. They're graffitied, and it is a busy street. And so many people can try this on their own. While DALL-E does require a special access to get in, DALL-E Mini is a easy way for people to get a little bit of a taste of this. And as a matter of fact, I do have a DALL-E access, so we will actually go play with it ourselves. So let's go move over to that. There we go. Okay, so we'll do this in a Mad Lib style. Oh, you have a question?
It is with an asterisk. You have to sign up and then get accepted off the beta, and then you have a certain amount of money. Is it? Oh, very nice. I'm gonna sign up for that then.
All right, well, I guess we'll just try this together. So we'll do this in a Mad Lib style. So we'll start off. I'll ask everyone like a noun, subject, or whatever, and then you raise your hand and give me something, and we'll try to generate it together. So we'll start off. Someone just give me a noun. Raise your hand if you want to give me a noun. Yeah, I see your hand. Kool-Aid Man. How do you spell? Is that with a K? Someone else type that. All right. Someone else give me an adjective. It's an adjective to describe our Kool-Aid Man. Driving. What? An adjective? What?
Well, that's a verb.
Sorry. You want to try again? Wait.
It's fine.
Okay. Okay, let's choose someone else for an adjective. Sorry. Raise your hand if you want to give out an adjective. I see your head, yeah? Sweaty. Okay, that's great.
Oh, boy.
All right. I'll take a setting. So like a place, a time, that kind of thing. A setting.
Vegas.
Vegas. All right, Vegas. So a sweaty Kool-Aid Man driving in Vegas. All right, and then last thing, we're gonna give it some artistic flair. So notice how in the previous example I said realistic. We can also say in the form of a Picasso painting, something like that. Yes. Claymation. Okay. All right. We'll see if it can do it. It's not perfect, but we'll see how it goes. All right, it's loading. And again, apparently, I guess this is open. It's pretty good, right? It's what we gave it. didn't do that bad. They didn't do that bad. Not too sure what the fourth image is, but we could say the second one, first one. Yeah, they're pretty good. All right. So we'll go back to the presentation. We had our fun.
Okay. Next slide. Sweet. Okay. So the other model that we wanted to point you guys to is called AI Dungeon. More or less, if you guys are familiar with like text-based games from like 1980. Yeah, where it's not just made of text, but you just get a sentence and you say what you want to do and the thing does it for you. So it's that built off of GPT-2 or 3, depending on the version. That is a natural language processing machine learning technique, more or less built off of what's called the transformer. I can't explain it really. It's very complicated, and that's all you're going to know because we're not going to get into it. And then it creates an adventure for you based off stuff that you give it, and based off your responses, you got to keep going on whatever adventure that you set up. It's pretty neat. You can play with it on your own. We could also set it up here, but it takes a bit of time to get going. So yeah, it's a lot of fun and definitely worth checking out.
We will share all these slides with you guys. So if you want to go look
Yeah.
these up, we have the links all here for everyone.
And we'll be posting it in the Discord. So if you're not in our Discord already, then you can scan the QR code we're going to have up at the end there and join and see the slides that way.
So that's the end-ish of the meeting. Stick around. We'll
Not
get more
quite done.
information about future club-related things, including the Sky is the Limit Challenge. So stay here.
So some information that we wanted to point to you guys about ACM. We have two new officer positions. We have two new officer positions. We have our hackathon coordinators and a graphic designer. So later in the spring quarter, we are going to be hosting our Hack ACM 2023 competition, or well, not necessarily a competition. It's open to everybody regardless of experience. If you would like to join the board in coordinating all of this, there will be a QR code at the end of the meeting that will take you to a Google form link. So please sign up for that. I will also be here in the front taking names and emails. So that is one of our positions. And then we also have a graphic designer. You will be responsible for creating ACM merch designs, flyers. You'll be creating posts for our social media, all of that sort of stuff. So if you're interested in any of that, please sign the Google form or come to me at the end of the meeting.
All right. Mentioned this last week, but we're going to go at it again. The logo challenge is still open. We're looking to redesign our logo. We're doing a bit of a soft reboot this year. So if you are interested, please be sure to submit the logo to this link. It is also posted in our Discord from last week. We'll post it again. Redesign our logo. That leads you to a design document with a couple of specifications. Have it in by the 17th. We'll announce the winner by the 24th.
This is for the artificial intelligence.
Yes. Forgot to mention, specifically for the Santa Cruz Artificial Intelligence Club, their logo is awesome, but we want to get ours to be even better, perhaps even better than theirs. So yeah, if you're interested, the slides will be posted. I'll also post a link and an announcement. So join the Discord, everything will be there. Next slide. All right. Now, for people who are interested and have a bit of experience, I'm going to be announcing the theme of our fall design challenge. So to reiterate, this is for people who have a lot of experience and want a bit of a challenge over a longer period of time. This competition is going to run until the end of November. So if you are interested, start work now as soon as I announce this, more or less. You're going to need to find your own data. You're going to need to come up with how it's connected to the theme loosely, and then just be sure to present your results once you're all done. That is basically how it's going.
Also, this could be done both individually or with a group. We want everyone to challenge themselves, whether or not they do have an experience. It's great to put on your resumes as a project. And again, we will have prizes. We haven't got that sense done yet, but we hope to have a company sponsoring this.
Very soon.
Additionally, if you are at all interested in this, in participating in the Sky is No Limits challenge, we would like for everyone that wants to come up to the front at the end of the meeting. Hopefully we can talk more about it, network a bit, and also find teams if that's what we're interested in doing.
Yeah, there is also already a channel on the Discord for coordinating that sort of stuff away from meetings. And we'll also put out a Google survey with the people who might want to pass some information to us about what they're looking for. So without further ado, here's the theme. The depths below. Take this to mean whatever you want. You could do something specifically about the ocean. You can do something about the sea, the animals in the ocean. It doesn't matter, so long as it is loosely connected to the depths below in some way. If we can identify it as being reasonably connected or loosely, doesn't matter, that fits. Again, competition is going to run until the end of November. You're going to need to find your own data, write a model, whichever one you want, and get something interesting going. And I'll be up here to answer some more questions if people are still interested. Yeah, that's going to be the end of our meeting. Our Discord's up there. If you're not in it, feel free to scan and join. We'll be posting these slides there as well as the recording.
This was a bit of a short meeting. Again, we will start the actual clusters, which will go into more depth about different types of artificial intelligence. So next week, we are starting on clustering, which is about getting data and putting them in where they cluster and group up together based on simulators of data. So we'll have 2 weeks on that, and those meetings will be a bit longer. Again, this was just an intro meeting, and thank you everyone for showing up. If you were interested in being an ACM officer, go meet Arish. Arish, can you go on the percent? If you're interested, go on the right. If you are interested at all at the AI competition, the sky is no limit. Please come forward and talk to us. We'd love to meet everyone.
Take care.
Back and each other and talk to me and quite a bit.
Interested in the hackathon.
Yes.